Well, good day. Today is Chemistry A, Unit 1, Atomic Theory, day number 3. We're going to continue to talk about the atom. And we're going to talk about today ways to distinguish the atom. In other words, ways to tell one atom apart from another besides just the proton. So first of all, let's talk about the atomic number. The atomic number is the number of protons in the atom itself. Every atom has a unique number of protons. Example, hydrogen has 1. All hydrogen atoms throughout the universe all have 1 proton. Gold, which we've talked about already, has 79 protons. Therefore, its atomic number is 79. Gold in them thar hills in California have 79 protons, just like the gold here in Michigan has 79 protons. Therefore, the atomic number is 79. And finally, third is carbon. Carbon has 6 protons in it. Therefore, its atomic number is 6. So if an atom has 56 protons, its atomic number will be 56. If the atomic number of an element is 112, that means it will have 112 protons. Now the mass number is another way to distinguish atoms. Now remember, mass is all of the particles in the atom added together. So if you look at our screen, it says protons plus neutrons. Time out. Time out, you say. You said all of the elements, all of the particles that are within the atom. You, Mr. Pack, have forgot the electrons. Well, let's go back. We said that electrons basically have no mass. If you wanted to add P's plus N's plus E's to come up with mass number, every time you would add up 1 plus 0. Because remember, we don't count the electrons as having much mass at all. So mass number is protons plus neutrons in the nucleus. The nucleus is where all of the mass of the atom is. And since that's where all the mass is, we only need to worry about the protons and the neutrons. So there's 2 ways to show the mass number. 2 ways to document, to write this out. We also use this to show the isotopes. First of all is symbol subscript. So for example, 197. 197 is the mass number. Okay? Our symbol for gold is AU. Mass number is 197. The atomic number is 79. Now what does that mean? Well, that means 79 protons, and the mass number is 197. So how many neutrons do we have? Well, that's simple. Subtract 197 and 79, and that will tell you the number of neutrons. Okay? So that's one way to show mass number. Another way to show mass number is AU, which is the symbol, 197, which is the mass number, and then subscript 79 is the atomic number. Now, when you take the ACT test uses this format right here. That's the 197 over the 79 next to the AU. The Michigan test that you will take as a junior, the MME, lists it AU 197 subscript 79. These two mean the same way. So this is one way to show. Symbol subscript. The other way is simply the name of the atom plus the mass number after it. So gold, AU 197, or gold 197. This tells you what the mass number is. Okay? Another way to distinguish amongst atoms are isotopes. Isotopes are atoms which have different number of neutrons but the same number of protons. So let's take a look at neon. Here we have a neon atom that has 10 protons and 10 neutrons. Okay? We call this neon. But if you wanted to show mass number, not as an isotope now, but if you wanted to show it as a mass number, we would say that this is neon 20. It's neon 20 because it has 10 protons and it has 10 neutrons. Excuse me. If we look at this atom, we call this neon 21. It's called neon 21 because it has 10 protons and 11 neutrons. Neon 21. Look what number does not change. Protons. That is the number that is not changing. The only number that is changing is the neutrons. Mr. Pack, what about the electrons? We don't care about the electrons right now. We are talking about isotopes. That number can be anything else. Right now we're focusing on just the protons and the neutrons. So if you take a look at this atom right here, this is neon 22. I know that because it has 10 protons and 12 neutrons. It is neon 22. Okay? Now, keep in mind, with isotopes, they have the same chemical characteristics because they have identical number of protons and electrons. Okay? So even though it's neon 20 and neon 21 and neon 22, we would say that they all have the same chemical characteristics because they have the same number of electrons as well as protons. And remember, electrons are responsible for chemical behavior. I'll repeat that. Electrons are responsible for chemical behavior. Therefore, isotopes all act basically the same way. And another way to distinguish between atoms are called ions. Ions are atoms which have different numbers of electrons but the same number of protons. For example, fluoride. Now, with fluoride, we know that fluoride has a nucleus, and we're going to color it in here. Okay. Inside that nucleus, it has protons and it has neutrons. And flying around the outside of that atom are the electrons. Okay, excuse my awful drawing abilities. Okay. Basically, what we need to keep in mind is that when the protons equal the electrons, it's not an ion. So when P's equal E's, it is not an ion. Okay? It is an atom. So we have our electrons flying around outside here. All right? So when P positives, those are the protons, equal E's, that is called an atom. Okay? When the P positives do not equal electrons, we call those ions. Okay? So, isotopes and ions, two different comparisons, two different ways to distinguish. Remember, with isotopes, it's protons compared to neutrons. And when it's ions, it's protons compared to electrons. The number that never changes is the proton. Okay? Now, for your discussion tomorrow, make sure that you know how to write the symbols for isotopes and be able to identify the charges of ions. We will refresh this tomorrow before we move on.